right, so in this next lesson, we're going to continue on our scatter plots. And so we're going to talk about what I have called lines of best fit. The book calls them trend lines. They're the same thing. It's just as I taught it in Leavenworth, we called them lines of best fit because we're trying to draw lines that best fit the data. And so we felt that that made more sense to students. You have a vocabulary word to make sure you go define. We're just going to move right into our key concept. Like I said, trend lines, you will hear me refer to them as a line of best fit or lines of best fit. Again, it just because we're trying to find a line that best fits our data. So as you can see, there were little speech bubbles that I cut off. So this first little speech bubble talked about the fact that these trend lines, these lines of best fit, should be as close as possible to each data point. So what that means is I'm not like, maybe I know that has a positive association, but I'm not going to draw a line clear down here because then I'm not close to these these data points at the top. So I'm wanting my line to be as close as possible to each data point. The other thing that we're wanting to keep in mind is that there should be approximately as many points as many points above and below the line. So what that means is, like, if here's our line, we have 1, 2, 3, 4, 5, 6, 7, 8 points below the line. We have 1, 2, 3, 4, 5, 6. So we're approximately, I would also, this is more above than below, so maybe we can say that's 7 instead of 6. So there's approximately the same amount of points above the line as there is below the line. And sometimes, depending on where your clusters are, that or any outliers that can affect your ability to draw that equally. All right. So moving on to our first example, which of these lines shown are reasonable trend lines for the scatter plot? So let's start with the red one line. We go through 2 points. If we were to describe these points based off of like clusters and outliers, I would call these 2 points outliers. That being said, they don't match our data because our points here have a negative association. Remember, negative association means that as x increases, our y values decrease. And this red line is actually showing a positive correlation, but really it goes through 2 points and is not following the rest of the data. So red is out. Purple is showing a negative correlation, but I would say it's not really following the trend, right? We're going through 5 of the points, and we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So approximately the same on either side, but I would not say that we are as close to as many points as possible on that one. Right? We're close to 5 points because we go through 5 points, but it doesn't match the direction of the points. So I would say purple is a no-go. Whereas when we look at the green line, we have approximately the same number of points on either side. We have a cluster here, so that kind of affects things. But it matches, out of these three lines, it is the best one to match the way the data points are correlating, or that association of our data point. Excuse me. So I would say green line, and the reason is because it represents a negative association. Association, and is close to many of the points of the data points. So again, that green line just is that best fit of the data. That's why instead of calling it a trend line, I tend to call them a line of best fit. I'm looking for that line that best goes with my data. All right, let's look at so we're going to talk about what are steps to writing an equation of a trend line. So once we draw our line of best fit or our trend line, we just identify any 2 points on this trend line. Try to choose easy points. These do not need to be data points that are already on the graph. They can be points that are just on your line that you drew. But if you can get some whole number values, that makes it easier. From there, it's just following the same steps that we had before. Find the slope. So you're going to take those 2 points that we identified, y minus y over x minus x, in order to find that slope. You're going to find the y-intercept by using the skills we used before, that slope, and a point on your line to find your y-intercept. And then you write your equation of that line. So the only difference here is we're having to create a line and then pick points off that line. Or your line will be created and you got to pick points off the line to use them. So let's get moving and grooving on our last example. So our first thing that we want to do is draw a trend line, and I'm going to add me some points to help me with this. So the red points I'm adding are actually going to be the points I'm going to use, but because I am drawing on this nice little sketch pad, it's easier for me if I have more points to try to sketch through. Not that it's helping with that one right there. All right. I'm going to sketch this line and I will be right back. And you'll have a nice pretty line just appear. Pretty as I am going to be able to get it. So here are my 2 points that I am going to use. I'm going to pick this one. So that's at about 1, 8. So write the 2 coordinates of the point. So I'm using the point 1, 8 because that's on my line. And then I'm going, this one's not at whole numbers. I'm going to come up here where this one was approximately whole numbers. I'm supposed to go through it. Don't tell anyone. And that's sitting at 4, 16. So those are the 2 points I'm going to use. Notice that those points were not data points that were already existing on or in our graph. Those are points that I picked off of the line itself to make it an easier way to write the equation. All right, so from here, we need to find our slope. So m equals 16 minus 8 over 4 minus 1. So I end up with 8 over 3. So that's our slope. M equals 8 over 3. I'm going to choose the point. So we have m equals 8 over 3. And I'm going to choose the point 416. It would be okay if you chose the point 18 because you should get the same equation. And I'm going to plug in. Y is 16 equals 8 thirds times 4 plus b. And we're going to have to work with fractions. Don't be afraid of them. 8 times 4 is 32, so we have 32 thirds plus b. In order to get b by itself, we're going to have to subtract by 32 thirds. And I know that if I take 16 times 3 to make it into thirds, I end up with 48. So this is the math I'm actually going to do. I'm going to do 48 thirds minus 32 thirds. because I need those like denominators in order to subtract. And 48 minus 32 equals 16. So our b value, those go away. So b will equal 16 thirds. And so now all I have to do, because I found my m, I found my b, I write the equation like we were doing in, what was that, 3.1, 3.2, those lessons. So y equals 8 thirds x plus 16 thirds. And that is our final answer. So we're using skills we used before. The only difference is now I'm taking data points. I'm going to have to estimate a line as best as I can through those points, and then pick 2 points off that line, excuse me, in order to create a line of best fit. That is it for this lesson. Until next time, 8th graders, deuces.